All right, today I'm going to be going over 19.2 transforming quadratic functions. And by the end of this lesson, you should know how to obtain a graph of g of x equals, and this is the vertex form, a times x minus h squared plus k for the graph of f of x equals x squared. So I'm going to go ahead and jump to page, let's see what page it is, page 908, which is explain 3. So I'm going to do this just a little bit backwards, just because I want you to understand where we're going, and then let's build the pieces to it. So for explain 3, it's basically graph this. How do you graph this? So the vertex form of a quadratic function is this, where h and k is the vertex. So if you look at this, let's say I put the number 3 here and the number 4 here. That would mean my vertex of my parabola, that point here, right, that vertex would be h, which I just put as 3, and k, which is 4. So let me erase those numbers and give you different numbers. Let's say h was 4 and k was 2. Then my vertex would be, okay, h, which is 4, and 2. Notice that this negative here, we're not really taking into account because we just want the value of h. H is my vertex, not negative h. But what happens if I had plus 3? That would mean that h is actually a negative 3 in order to make that negative a plus. So let me explain that one more time. If I had x minus negative 3 squared plus, let's say k was 5, in order to get a plus, wouldn't that have to be a negative times a negative? So in this case, h is actually negative 3. Do you see that? H is negative 3. So what we do when we find our vertex is we switch the sign of the h and we keep the sign of the k. So if I'm looking at this one here, h is the one inside, you switch the sign and you make it negative, and you keep the sign of the k. And notice the vertex is negative 1, negative 2. For b down here, it says identify the vertex. So here is negative 1, we switch the sign, so it's going to be positive 1, and we keep the sign of k on the outside. So my vertex here is going to be 1, negative 7. And then the reason that I chose to start with example 3 first is because I kind of want you to see the whole picture. So let's go through example 3a together, and I'm going to show you how I would graph this. So the first thing I would do is identify my vertex. You need your vertex first. And we just found our vertex to be negative 1, negative 2. So let's plot that. Negative 1, negative 2. And now your amplitude, that A in front is like slope. It's not quite slope, though. So 2, I'm going to say use your amplitude. And what we're going to do is we're going to use our amplitude to find another point here. So I'm going to go as if this was slope, and I'm going to go down 3 and over 1. And remember that this is symmetrical, and your axis of symmetry always goes through your vertex. So my symmetrical point is going to be here. So if you already see, we have this sketch of what my U is going to look like. But the book likes you to make a table, find 2 points on each side of the vertex. So the book wants you to put your vertex here, and then choose the 2 points, 0 and 1, like the 2 points to the right and the 2 points to the left. So if I'm at negative 1, the next point would be 0, 1, and the next points back would be negative 2, negative 3. And if you plug those in, you would actually get those same points that I just found for you at negative 5. See that? 0, negative 5, negative 2, negative 5. But what's nice about what the book has you do is if you do this, you'll actually have another point. So here we would have negative 3, negative 14, and that gives me a better sketch of my graph. It's symmetrical, so this number is going to be the same as this number over here. So 1, negative 14. Right, if I just did it off of these 3 points, I could have said, oh, my graph looks like this. But that's actually not what your graph looks like, right? We found those other 2 points. Let's sketch it using those points. It's very narrow, and it should look like this. Okay, so let's try that for B. Let's start fresh. Let's look at it and say, okay, what were my steps that I needed to do? Step 1 is to find your vertex, and step 2 is to use your amplitude. So step 1, my vertex, remember your standard form was ax minus h. Not standard form, your vertex form. A times x minus h squared plus k. So if I'm looking at this, h is this number in here, and you always flip the sign of what's in here. So my vertex is going to be positive 1, and then my k is going to be negative 7. So I'm going to plot that here, and I'm looking at this graph, and I see that they're counting by like 3 is this mark, which makes this 1.5. So I'm not really sure why they're labeling theirs the way they are. So I'm actually going to relabel theirs. So I'm going to call this 1, 2, 3, 4. This would be negative 1, negative 2, negative 3, negative 4. Same thing going down. I'm going to call this, or going up, I guess, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to count by ones. So this is negative 2, negative 3, negative 4, negative 5. Okay. So I have my vertex at 1, negative 7. So I need, there we go. Maybe that's why they were counting by threes. So here is negative 6, negative 7. So there's 1, negative 7. And my amplitude is up to 1, 2, and over 1, up 2, and over 1. And I'm going to sketch my graph. Now, if we wanted to use the chart that the book uses, we would put our vertex here. We would plug in the point 0, we'd plug in the point 2, and we would find these values. But I'm going to use these steps here in order to graph.